Okay, so this morning you're working through the past paper trig questions that I've set you that have come from numeracy papers. Now in general, the trig questions on a numeracy paper are actually less complicated than they are on a maths paper, but the challenge is actually lifting the right angle triangle that you need to work with out of the context of the question, and also possibly spotting that it is actually a trig question that you need, or a trigonometry that you need to use to answer the question. So it's really important you read through the whole question before you actually start doing anything. So the diagram shows the route a dolphin swam from Port Key to Rig Bay and then to J Cliff. So this dolphin, starting there, he's swimming from there to Rig Bay and then to J Cliff. And then if you look at the north line there, you can see that it's creating a right angle triangle. Rig Bay is on a bearing of 232 degrees from Port Key. The distance from Port Key to Rig Bay is 3.2 kilometers. Calculate how far the dolphin swam altogether. So highlight the actual question, the instruction. What are we needing to get a final answer for? How far the dolphin swam altogether. So the dolphin swam from Port Key to Rig Bay and then to J Cliff. So the dolphin swam that distance and that distance, and that's what I'm going to need to do to answer this question, is add those two distances together. So I know that the distance from Port Key to Rig Bay is 3.2 kilometers. So Port Key to Rig Bay is 3.2 kilometers. And then the other piece of information they're giving you is to do with the bearing. Now we haven't revised bearings yet, but hopefully you will have covered them before. And the way that a bearing is measured is always clockwise from north. So when you measure a bearing, north is 0, and then you're turning in a clockwise direction through the given angle until your line of sight, in this case, which is Rig Bay, you're facing what you're looking for. So with this one, it's that angle there that is 232 degrees. So if I know that all of that is 232, I know that from north to south is a straight line. So that's 180. So the angle that's inside that right angle triangle is going to be 232 less 180. So 232 less 180 equals 52 degrees. So what I would do then, just like when we were looking at the maths past papers yesterday, is out of that complicated looking diagram, just pull out the right angle triangle that we are going to apply trig to. So that's going to be PRJ. I know that this angle is 52 degrees. I know that that side is 3.2, and I need to work out that side so that I can add those two together then to get the total journey distance for the dolphin. So we then name our sides just like we were doing yesterday. 3.2 is the hypotenuse, the unknown side is opposite, and the one that's left is the adjacent. So if I knock out my so-called towers, I need to have the opposite in it because I'm trying to find it, and I need to have the hypotenuse in it because I know it. So the one that links opposite and hypotenuse is sine. So this is the one I'm going to use. Cover up what I'm trying to find, which is the opposite. The S and the H are on the same line, so it's a multiply. So op is sine times hyp. The opposite is RJ, that's what we're trying to work out. Sine is always linked to the angle, which in this case is 52, times the height, which we know is 3.2. So on my calculator, type that in exactly as we see it. Sine 52 close bracket times 3.2 equals 2.5. So now we need to check back to the highlight. What's our instruction? Calculate how far the dolphin swam altogether. Well, that's not the answer, because that's just the distance between Rig Bay and J Cliff. So dolphin swam 3.2 plus 2.5 equals 5.7 kilometers. Okay, so that was that one. Question 2. So remember, trig questions are grade B questions. So they're going to be in the second and later part of the paper. They'll always be on the paper 2, where you're allowed to use a calculator. So the diagram below shows where Levi wants to attach a string of lights to his house. So they're going on the apex there. Levi wants to attach a single string of lights from B to A and then from A to C. The diagram below shows the measurements Levi has taken. So we can see we've got a triangle. Its isosceles, AB and AC, are the same size, same length, which means that that angle and that angle are also the same. And when you cut an isosceles in half, you're going to cut the base in half as well, which produces a right angle triangle for us. He spends £410 at the electrical store buying a string of lights. After putting up the lights, Levi finds he has 6 meters of the string of lights left over at one end. So here's the command. How much did the electrical store charge Levi per meter for the string of lights? Well, that's going to give me an answer in pounds, cost. So I've got a fair bit of work to do to take from my right angle triangle. So what I need to do, I know that after attaching the lights from B to A to C, he's got 6 meters left over. So in order to work out how many meters he actually bought, first of all I've got to work out how much, what length of lights go from B to A and A to C. So to do that, I'm going to use trig, because what I've got, and again I'm just going to strip out my basic triangle that I'm going to use. That's a coincidence that that angle is 52 as it was in the previous question. I know that this distance is 2.5 and I want to find the length of light that's going to run from A to C. So name my sides: opposite, hypotenuse, adjacent. So this time I need the trig group which has got A and H in. So if I just write them up here, so car tower, the one that links A and H is cos. I want to find H, so when I cover up H, I've got A on top of cos. So H or hype is adj on top of cos. So hype is what we're trying to find, so that's AC equals the adjacent, which is 2.5, divided by cos, and the angle's always linked to the trig button. So I can type this on my calculator exactly as I see it. You put that in brackets. So fraction button, 2.5 on top, cos 52 equals, so that's going to be 4.1 to 1 decimal place. So 4.1 meters. So that's the trig dealt with. What I now know is that the distance from there to there is 4.1 meters. The distance from there to there is 4.1 meters because it's isosceles, and he's got 6 meters left over. So the total length of lights he buys will be 4.1 plus 4.1 plus the 6 meters that he's got left over. So he's bought 14.2 meters of lights. So now go back to our highlight. Have I answered the question? How much did the electrical store charge Levi per meter for the string of lights? No, I haven't answered it yet. What I do know is that 14.2 meters cost him £410. So if I want to work out the cost per meter, I've got to do 410 divided by 14.2. So £28.87. Alright, so £28.87 would be acceptable if you'd have rounded those off to 4 meters and then worked out 14 meters or 15 meters. That would have been acceptable as well. So hopefully you can see that what's happening here is the trig is straightforward once you lift it out of the question, but there's often more bits to the question than just working with the triangle, which is what would happen on a maths paper. Question 3. Ursula is lying on her surfboard 180 meters away from the foot of a vertical cliff. The height of the cliff is 146 meters. So there's the diagram. So she's out here on the surfboard. She's 180 meters away from the base of the cliff. The height of the cliff is 146 meters. So I could join those, and lo and behold, I create a right angle triangle. Ursula was told that if the angle of elevation of the top of the cliff from her lying position is between 42 and 45 degrees, it is safe for her to attempt to stand up on her surfboard. Calculate the angle of elevation of the top of the cliff from Ursula's position on the surfboard. So there's an instruction, but then there's more. We have to state whether it's safe for her to stand up, not safe if she's too close, or not safe if she's too far. So I need to get a figure for the angle of elevation and then compare that to whether she's between 42 and 45 degrees to work out whether she's too close or too far away. Angle of elevation is the angle her head would turn through as she went from lying on the surfboard looking straight ahead to turning her head up to looking at the top of the cliff. So the angle of elevation is there. So we've got a right angle triangle. We want to find the angle. We know that this is the hype. We know that this is the op. And we know that this is the adjacent. So when I'm finding the angle, I need to have the trig ratio, trig group, which has got the two sides I know. So when I'm doing my SOH, CAH, TOA, I'm looking for the group that's got O and A in, which is tan. So use that one. When I'm trying to find an angle, it's the trig letter that I'm covering up. So tan of the angle is op over adj. So tan of x is 146 over 180. Remember from when we were practicing these yesterday, I said that when we're trying to find an angle, we've got to get the x on its own, so we have to do the opposite of tan, which on your calculator is shift tan, and if you look at how that's written, in yellow it's tan with a little -1 above it. So on our calculator, we type that in exactly as we see it. So shift tan, fraction button, 146 on the top, 180 on the bottom. Okay, so it's exactly as we see it. Press equals, and it's 39 degrees. So the angle of elevation there is 39 degrees. So job 1 done. I've calculated the angle of elevation. Now I've got to say whether it's safe or unsafe. For it to be safe, she's got to be between 42 and 45. So she's outside that limit, so it's unsafe. But then I've got to say why. Okay, so is it not safe because she's too close or too far away? Now if that's 39, if she was, the closer she gets to that cliff, the steeper she has to look up at the to look at the top of the cliff. So if she's there, that's going to be a much steeper angle than it is there. So angles this side of 39 would of 42 and 45 would be steeper. She's at an angle of 39, which means she's further away, because that then means a much shallower angle to look up. So 39 degrees means she's out there, she's too far away. So it's not safe as she is too far. So there are 4 marks for that question. 3 of those marks would be for calculating the 39 degrees, and then the 4th mark would be for correctly saying it's not safe because she's too far out. Question 4. The diagram shows the cross section of one part of her run. So I've snipped out part A of this because it had nothing to do with right angle triangles. But it's about a lady who's on a run, and she's running up a hill. So she's running along the road there. We need to calculate the angle of elevation. Well, we just discussed angle of elevation in the previous question. It's the angle looking up from the base to the top. So if we name our sides, we've got opposite, hypotenuse, adjacent. So just like in question 3, I need to have these two in, which are opposite and adjacent. So I'm going to be using the tan relationship. When you're trying to find the angle, tan of x is opposite over adjacent. So tan of x 200 over 1600. To get the x on its own, we do the inverse tan. So on calculator, shift tan, fraction button, 200 on top, 1600 on the bottom, close the bracket, 7.1 degrees. Gwenda runs on a section of uneven road from A to B. The rise in this section of the road is 300 meters, and the angle of elevation of B from A is 10 degrees. Calculate an estimate of how far Gwenda has run. State any assumption you have made. So the assumption I'm going to make is that that uneven road is not far off a straight line, so that I can make a right angle triangle. So what I'm actually going to do is deal with this right angle triangle. I'm going to ignore the uneven road bit, and I'm working with 300, 10, and I wanted that distance there. This is my opposite, that's my hypotenuse, that's the adjacent. I need to have opposite in because I know it. I need to have hypotenuse in because I'm trying to find it. So straight away as I go to write SOHCAHTOA, I can see the one that I actually need is the first one, which is sine. I'm trying to find the hypotenuse, so it's opposite on top of sine. So the hype equals op on top of sine. So the hype is what I'm trying to find, is it, which is 300 on top of sine, and sine linked to the angle, which is 10. We type that exactly as we see it. So fraction button, 300 on top, sine 10 underneath, and we get 172, and let's round it to the nearest whole number, 1728 meters. If you round it to one decimal place, that's fine. So what assumption have I made? That the road is pretty flat. What's the impact of the assumption on my answer? Well, if the road was pretty flat, be 1728. If it was more undulating, if it was more up and down, then she might have run further, because the distance, if you imagine that rough road was a piece of string that I could pull tight, then it would be longer than the distance AB. So she has actually run further than this. Would be the assumption. Okay, 2 more to do. So Yared is going to make a door wedge. The cross section of the wedge is shown below. The horizontal length is 12 centimeters and the vertical height is 3 centimeters. So we're going to have that's what the door wedge is going to look like. Calculate the length of x. So with this one, they haven't really disguised the right angle triangle at all. But what they have done is they've mixed up here a little bit of trig and a bit of Pythag. So there's 2 ways you can work that out. Because I know 2 sides, I can use Pythagoras to work out that. So let's do it 2 ways just to show you. So we can either use Pythag, and to work that out, x, and this is the way we were doing it when we were practicing this last week, is going to be the square root, and we're trying to find the longest side. So it's going to be squaring your sides, adding them together, and then square rooting. So we could do square root of 12 squared plus 3 squared and get that x is 12.4, or, oh no, there is no or, sorry, I don't know that angle. That's the only way to do that. So it's not either or. At the moment, it is just Pythag. What you could do is work out angle y first, and then you could use trig to work out x, but this stage we're not going to do that. So the wedge would fit under Yared's door. The angle y must be less than 15 degrees. Show that this wedge will fit under Yared's door. So now I want to find that angle y and see if it's more or less than 15 degrees. So name my sides: opposite, hypotenuse, adjacent. Now we've worked out the hypotenuse, so we've got a choice what we want to use, but what I would always suggest, in case you've worked that out incorrectly, use the values that you're given in the question. So I'm linking opposite and adjacent. So when I do my SOHCAHTOA, the one that links opposite and adjacent is tan. So use TOA. I want to work out the angle, so I'm going to cover up the T. It's op over ad. So tan is op over ad. Tan of Y is opposite, which is 3, over adjacent, which is 12. To get the Y on its own, we have to do the inverse, which gives us that. So on our calculator, shift tan fraction button 3 over 12 close bracket is 14 degrees. And then the full question. Calculate the angle of elevation of the top of the Eiffel Tower from the point P. Right, so let's assume that Eiffel Tower is going to be perpendicular to the floor, which means we've got a right angle triangle. We know that this is 324. We know that that is 800. And we want to find out the angle of elevation there. So I've got my op, I've got my adj. Op and adj we've used a lot now, so hopefully you'll be happy that that is tan. We cover up the T, so tan of x is op over adj. Tan of x over 800. X is the inverse, tan minus 1 of 324 over 800, which comes to shift tan fraction button 324 800 close it 22 degrees, which you can see there from the answer is correct. So that's it. Got a week of Trig this week, following on a week of Pythag last week, so hopefully that's really refreshed your memory and you can get stuck into those questions with confidence.